So Alex, we're looking at true infrared grill here. It says charbroil true infrared grill. Tell me about these grates.
Okay, this type of grate here utilizes the hot gas from the burner system to heat up the bottom of this and radiate heat to the food. The way it does this is you'll see we've got a lot of little small holes here. When the hot gas from the burner hits those holes, it slows down abruptly because it can't go very fast through a small hole. When it slows down, it transfers a lot of heat to the metal here. That forms the radiating surface in here that could be 600 to 800 degrees and radiates intense infrared heat right to the food that's right above it. But because this is coming up at a slow velocity, it's not drying out the food very much. So imagine my hand being the piece of meat. You see that my hand is absorbing infrared radiation from the bottom of these surfaces that have been heated by the gas coming up through these small holes. And we'll see when you cook that the grease that comes down from food won't ignite underneath there because the oxygen from the air, freshly charged oxygen from the air, can't get in between the meat and the hot surface where the grease is in order to create a fire. As you see, when these grates are first made, they're made of stainless steel, which is a long-lasting rust-free material. But when it first comes out of the mill, it's bright and shiny. When you heat it to the temperatures that we heat at, it turns dark. When it turns dark, it emits more infrared radiation. And that's inherent to the physics. We were talking about that earlier, about the shirts and the color of the shirts.
I'm going to place this meat. There's some nice fat in here, and I'm going to listen.
It sizzles, of course.
So what do you think that temperature is right about there? These are pegged at over 700 degrees.
Right. The radiating surface is probably about 800 degrees. The top surface of the rib where the food is contacting is probably about 650. I see you're putting in hamburgers there that have a nice mixed fat content.
Very much.
And already you can see what's happening. You see that you have smoke that comes down through there. There's a little fire underneath because some of the smoke goes down, some of the grease goes down through those holes, but it doesn't come up through the holes very much to burn the meat. In other words, you've got fire below, but the small holes prevent the flames from going through.
So we're not getting this horrible. You're still going to get some fire. You're still going to get, you got a lot of fat there.
Right.
So there's fat, there's fire.
That's really fatty food.
Yeah. Now, we can control that.
Exactly.
Prevent the oxygen from getting in.
That's right.
And that'll end it right there.
That's right. And you see all the smoke coming out. That smoke is from vaporized grease. The grease hits that surface, and instead of actually combining with oxygen, it just vaporizes like water would vaporize. And so what you're seeing is small particles of grease that are actually suspended as an aerosol in the air. And so they're coming out there and creating this enormous amount of smoke, which is a characteristic of this cooking system. It does this instead of having fires that burn the meat.
But then that's more flavor.
Absolutely.
We're getting some
smoke
flavor. And we know that flavors the meat.
Right.
So we've got a charbroil true infrared grill. We're getting at least 65% or better infrared.
Well, certainly because we've been operating at a high temperature, warming it up really hot, I'm sure it's very close to 70% infrared radiation at this point.
So that means less convection.
Yes.
So there's less drying out, higher temperatures, faster cooking, and virtual control. One thing I notice here is I've got an even heat look all over the entire grate.
Well, you'll always do that with the charbroil infrared grills because, again, this surface, because of the way that, well, let me explain to it looking at these. Because of the fact that we've got these holes over this whole surface here, the hot gas from the burners doesn't go through one section. It hits the bottom here and spreads out. So what's called the high pressure drop, going through these small holes, spreads out the hot gas from the burners evenly over the whole surface, which means the whole surface is heated to about the same temperature.